All right, so we're going to change gears. Brand new unit. Unit will only have 2 or 3 parts to it, but it's not going to be like the last unit, which had like 2,500 parts to it. This one's going to be really interesting because it deals with metallurgy. So I'm going to teach you a little bit about the chemistry of metallurgy, which is very important to us because metals are the foundation for our building materials. I can construct an activity series based on experimental data. I can use the activity series to predict whether a reaction will occur. All right, so you ready? An activity series is a list of metals in order from most active to least active. You can find one of these in the back of your periodic table. So everyone should have out their periodic tables because after all, this is chemistry. And we use a periodic table virtually every day. Now, what is the activity series really? It's a little black book. That's the expression that we used to use back before technology. Basically, you're a dude, and dudes seem to be worse about this than gals. You're a dude, you might have a little book where you rate all the girls in your life. It was your little black book. And you consulted the black book when you were trying to figure out who you were going to date. I once had a student who was very, very unwise. He was a sophomore. And he had a little black book. It was actually a spiral-bound book in which he had stick figures for all the sophomore girls with arrows pointing to their features, with a rating system between 0 and 10 in order to describe his opinion about their features. So, one day he made a tragic mistake of bringing it to school. I guess he wanted to show it off to his friends, his little black book, which was a spiral-bound notebook. Unfortunately for him, he left it behind in my class. So I'm minding my own business between class, and I see a small grouping of girls who are making very anxious and angry noises. And I realize there's something going on. So I kind of worm my way into this group, and the girl that was holding the book gave it to me like, "Whoa, you take care of this, Mr. Marino." And I looked at it and I said to myself, "Holy crap, they're gonna kill him." So I went and I called. We had a female vice principal who was a basketball referee. She was a dynamo. I mean, she was tough as nails. I really loved her. I knew that if I wanted a student to really get in trouble, I would make sure that she found out about it. So I called her up and I explained very quickly the information she needed to know. She came up here, she paged through, and she said to herself, well, she said out loud, "I'm going to kill him." Needless to say, for his own good, he got a 3-day vacation in order to prevent girls from annihilating him. And by the way, before I got a hold of the book, he had been ranked on the back page, and it wasn't very flattering. So that is the little black book, where he tried to express his opinion of which girls in the sophomore class were better looking than others. Think of the activity series as a little black book, telling us, helping us understand who is better looking than others. All right, so notice right here in this example, you've got zinc and nitrate. Imagine them as being a dancing couple. Okay, zinc is the guy and nitrate is the girl. And they're dancing in the watery solution. Along comes copper, and copper is introduced into the mix. For those of you who are not aware of how they used to dance back before your time, if a gentleman wanted to dance with a lady, he would go and tap the gentleman on the shoulder who was presently dancing with the lady. And it would be up to the lady to decide whether she wanted to switch partners or not. So the question is, copper is coming in wanting to dance with nitrate. Nitrate is presently dancing with zinc. Look on the back of the periodic table. It should be around 9 o'clock. Imagine the periodic table is a clock. Look for it around 9 o'clock. Do you see the activity series? Oh. On the left side is how the girls have ranked guys. On the right side is how the guys have ranked girls. So on the left side, we begin with the most beautiful, handsome, outrageously good-looking guy in all the world, and that is Isaiah. But since Isaiah didn't make it, I didn't know Isaiah in time to write this activity series, then it is lithium. But we all know it's really Isaiah first. Okay, so that is the best looking guy, and you can work your way down to the bottom. And who is dead dog ugly? Gold. Okay, gold. Now that is very interesting because there are only a few elements on Earth that you can find in their natural form in nature. And gold is one of them. You can go into a cave if you're very lucky and you own the cave and find a streak of gold on the cave walls, in which case you are now a very, very, very wealthy person. All you would have to do is tip it out, and there you go. Go and turn it into the bank, and they'll give you cash for it. Why? Why is it that gold can be simply found in a cave while all other metals are found in a mineral form? Because gold is so ugly that even oxygen, and oxygen does not have high standards, even oxygen will not react with gold. Why? It's at the bottom of the activity series. So, look at your activity series. Look up copper, Cu on there. Look up zinc. Bailey. If you're nitrate, I'm just going to call you Bailey nitrate. If you're nitrate and you're now dancing with zinc and copper tries to butt in, do you give copper permission? Bailey, take out your periodic table then. All right, I'm going to come back to you and ask you another question. Charlie, what do you say? You're dancing with nitrate. I'm sorry, you are nitrate. You're dancing with zinc. And copper tries to cut in. What would you do? Just say no. And why is that, Charlie? It's a downgrade. I mean, zinc may not be the best looking guy in the world, but copper is uglier. You're not dumb, right? No way. Okay, but let's change the subject. Let's see, I need another female. Bree Mac. Bree Mac, you are nitrate now, and you are dancing with copper. Find copper on your little black book, your activity series. And zinc tries to cut in. Zinc tries to worm his way in and dance with you now. What would you do? Is zinc better looking than copper? Is zinc higher up on the chart? Yes, zinc is better looking. So what would you say, Bree? Yeah, I mean, right now you're dancing with, okay, he's a dude, but he's not very good looking. And a better looking dude comes up and wants to dance with you. And you would say, yes, yes. If a single element is above the element in a compound, then yes, the reaction will occur. If a single element is below the one in the compound, then no, it will not occur. So, what would you actually see occur? Well, in this case, here's this dude trying to cut in and dance with nitrate with Charlie, and Charlie says, no. So, what do you lift up? Rejection. Copper came in, tried to cut in. Charlie says no. Copper leaves. Rejected. Very, very sad. Maybe a tear in his eyes. But how about this situation? Bree is now dancing with Copper. He's a dude, but he's not that good looking. And Zinc comes in and tries to replace Copper. And when you lift it up, look to see what is now on the zinc strip. A layer of copper. Where did that copper come from? It came from the reaction. Zinc replaced copper. So zinc is now dancing with nitrate, and copper has been kicked out. So copper is now in its natural form. So potassium, this is an example here. Potassium is the best looking. Iron is, of this bunch, the worst looking. You always want an upgrade. You always want an upgrade. So check it out here. Copper in zinc, notice nothing is happening, which means who's better looking, copper or zinc? Zinc. Here, zinc is going into copper, and notice all the copper appearing on the zinc strip. Who's better looking? Zinc. Zinc is always going to be better looking. Okay, we switch the partners. That's why it's confusing. All right, this is called a single replacement reaction, because how many elements are you replacing? One replacement element. So notice magnesium here coming in, replacing silver. Look on your chart. Look on your chart. Does this make sense? Is magnesium better looking than silver? Okay, so the reaction does occur. So here we have a situation where we have Taylor Swift, and she has a decision to make, because look at all the dudes that want to go out with her. All of these dudes want to dance with Taylor Swift. You don't think that Taylor Swift has a little black book where she has ranked all the guys that are interested in her? Probably. That's because she doesn't know you, sir. If she knew you, you would be at the top of the list. All right, so here are the four guys. I probably could not. Okay, this is Jake Gyllenhaal, right? These other three guys, no idea. No idea. All right, so this is her ranking. This dude is best looking. Then greeny guy is next, purple guy, and then Jake. Poor Jake. Jake is worse off. All right, so imagine you are Taylor, Bailey, and you are now dancing with this dude, purple guy. Green guy comes up. Will this reaction occur? Will you switch partners? You will not, even though green guy is better looking than purple guy. Then yes, you will switch partners. You disagree with her ranking? So, purple guy is better looking than green guy? What do you think, Isaiah, since, you know, you understand beauty? Oh, okay, Isaiah should be in the top of the list. Okay. All right, how about this one? Selena. Purple guy wants to cut in. Blue guy is dancing with you. What would you do? Stay. We say no reaction. I know this is hard for you, Emily, because you consider Fritz to be at the top of... All right, okay. But let's imagine that you didn't have a choice. And these are your four guys here. You are now dancing with Gyllenhaal. and purple guy tries to break in, would you say yes? Yeah. Thank you. Okay. And you ready? Valencia, Carter, you are dating Jake, and blue guy wants to come in. What would you do? Switch partners. That's right. This poor Jake, just not very good looking. All right, you do it now. We'll incorporate some guys into all this. Guys are going to have to imagine that they are a girl, and they have to make decisions. Conlon, you are copper and silver nitrate. And I mean, you are nitrate, and silver is now dancing with you. Copper comes in. What would you do? Switch partners. Let's see why. Let's see, where is everything? Where is copper? Copper is right here. Wow. She ain't very good looking. But then again, you're actually dancing with someone's even uglier. So Conlon, it's not much of a choice, but it's definitely an upgrade. So the reaction, does the reaction occur? Yes. All right, Isaiah, since you're so opinionated about things, you're sulfate and you're dancing with magnesium, and silver wants to come and replace her. What would you do? Okay, let's think about it. I'm glad you asked me that, or you said that to me. That's silver, right? She's by herself. She wants, because you are so good looking, Isaiah, she wants to dance with you. Ooh, she wants to dance with you. Bad. So she comes over, and magnesium is now dancing with you. And she taps magnesium on the shoulder, and magnesium looks at silver and then looks to you, because you're going to have to make a decision. Do you want to get rid of magnesium and then bring on silver, or are you fine the way it is? You're good. You're a wise man, because silver ain't good looking. And magnesium is actually, she's pretty decent. She's all the way up. I mean, she's not as high as you are, but she's all the way up there. Okay, so we would put down NR for no reaction. NR for no reaction. Cherish, you're going to play the part of nitrate, and you are now dancing with copper. So here's copper, here is magnesium. Well, this is the only one I got. Oh, well, go for it. Okay, so Cherish, would you make the switch? No. Okay, let's keep in mind, the higher you are up this chart, the better looking you are. Right now, you are dating copper. Magnesium wants to date you. What would you do? You would say yes. Timothy, you are sulfate. You are now dancing with potassium. Sodium wants to cut in. Well, it doesn't really matter, because you are sulfate. These are your choices. Will you stay pat, or will you stay pat, or will you exchange? You're staying? Okay, why? Well, sodium. Actually, sodium is pretty dang good looking, but yeah, potassium's better looking. Yeah. I mean, what's it like having two very good looking girls, one prettier than the other, wanting to dance with you? What is that like? Oh, excuse me, I'm sorry. Isaiah can tell us. Go ahead, Isaiah. You said you can tell us what it's like to have two very good looking girls wanting to dance with you. Oh, okay, all right. Potassium and magnesium. Ariola, ever had two girls gunning for you? Well, okay, maybe not, but let's imagine you are. You are now, oh, didn't mean to do that. You are now dancing with magnesium, but potassium wants to cut in. What would you say? You say, yeah, yeah, okay. So you would say, yes, definitely, yes, she's an upgrade. Even if even if magnesium's personality is really, you really like her personality, you're so shallow that you would switch for the better looking girl, even though she might be snotty and stuck up. Wow, wow, Austin, that is really shallow. And chemically speaking, that would be the correct choice. Because in chemistry, we don't care about your personality, okay? In chemistry, our saying is this: beauty may be skin deep, but ugliness goes all the way down to the bone, right? Right? All right, so you try this. Try it very quickly. And in a few minutes here, we'll check our answers. You mean the periodic table that I asked you to take out 15 minutes ago? I've got some more over there. You need those. Keep looking. Keep looking. Can we just write yes or no? Yes or no? Ari, you can do letter A. Yes or no? Is iron better looking than silver? Yes. Manuel, is copper an upgrade over zinc, who is your girlfriend now? So, oh, do you care that she has a nicer personality? No. She's ugly. No. And finally, Asai, is magnesium going to replace copper? Yes. Definitely an upgrade. Definitely an upgrade. How is this important? Well, the natural state of most metals is in the form of an ion as part of a mineral. So most metals are in mineral form. Okay? Let's put that away. Okay? No cell phones allowed. Name 3 ways in which metals are extracted from minerals in solid form: electrometallurgy, pyrometallurgy, and hydrometallurgy. For example, this is what I'm trying to get to. We use a lot of copper. Copper is in our wiring. Without copper, we cannot enjoy the life, the technology that we have today. Without iron, we can't have these beautiful buildings that are sky high. But here's our problem: iron does not exist in our world as iron. It does not exist as copper. It exists in a mineral form. So, for us as human beings, we made huge strides in civilization when we figured out how to take a mineral and convert it in the metal in the mineral into its pure form. Okay? The 3 ways in which we discovered was electrometallurgy, pyrometallurgy, and hydrometallurgy. It's been thousands of years since we've known about pyrometallurgy and hydrometallurgy. Only in the last 100 years have we discovered electrometallurgy, because that requires electricity. In electrometallurgy, we take really, really, really ugly elements that don't want to be we take very, very good elements that are already bonded to somebody, already dancing, and we force them to come out of the dance floor. The only way you can do that is through a lot of electricity. So for most of human history, we didn't know what sodium looked like in its natural state. Since electricity, we have figured out how to make sodium go into its natural state. Why have we never figured it out? Because sodium is so good looking that everything, all sorts of things, want to react with it. Pyrometallurgy is one of the earliest forms of metallurgy. And that was simply, you build a fire. What do you want to do to prevent the fire from spreading to where you're sleeping? What are you going to build around the fire? You're going to build a little barrier using rocks. Thank you, Bailey. Absolutely correct. Okay. At some point, they found some rocks that contain, for example, copper. And what they discovered in the morning when they woke up is that in a few of those rocks, there was now a shiny puddle, a solid, shiny metal that was sticking out from that rock. So they chipped it off, and now they had a piece of copper. Inevitably, somebody decided, hey, I bet we can make an arrowhead out of this instead of having a stone arrowhead. And now we have copper arrowheads. Then very quickly they realized the copper was so soft, it didn't work very well as an arrowhead. So they started testing different other types of rocks. And those rocks yielded different metals once you put them in the fire. And at some point they realized that you have the silvery metal that they called tin and copper together, you now have bronze. And bronze was tough enough to make into an arrowhead. Actually, our first swords were bronze swords. So if you heat a metal in a blast furnace with carbon, which is just charcoal, it will allow the metals to come out. And then what we're going to be using on Thursday is called hydrometallurgy. And that is where you use water water to dissolve the mineral, and then you add another metal to it, and it'll replace it, like all the examples we have seen so far today. Now, why is this so important to you guys? Because if you're building a building and you're not careful, you could get yourself into big trouble. For example, the Statue of Liberty. The Statue of Liberty is made up of these copper plates that on the inside, you can't see until you get on the inside, were held together by these belts that had both copper and zinc in them. Everything was okay until the insulation that was protecting the copper from the zinc wore away because rain was getting in. When that happened, the copper and the zinc started touching each other, and of course, the copper was replaced by the zinc, and then all of a sudden, these belts that were holding the Statue of Liberty together started coming apart, allowing more water to come in and causing more of this erosion. So because you had two different metals that are at different points on the activity series, you had this degradation. And they had to go in back in the 80s. They built this framework around the Statue of Liberty, and they had to basically disassemble her and build her in such a way that it would never happen again. This is back in the 80s with the Statue of Liberty completely encased in a cage. So this is what I was telling you guys about. You have these plates. You can't see that this is from the inside. You have these plates all held together by these bars, and the bars have these belts that hold them securely in place. That was copper. The bar itself was a different metal, and over time, the insulation wore off and the two metals started coming in contact with each other, and that caused the belt to warp and be twisted out of joint. And now you had plates coming apart. So the statue builders tried to prevent the metals from touching each other by placing shellac coated asbestos between the copper and the iron. Over the years, moisture collected in these spots and wore the asbestos away. By the late 70s, more than 40% of the 450,000 rivets had pulled loose. The holes in the copper plates were sagging. Statue exterior had suffered due to air pollution and acid rain. The copper reacts with the air to form a rust called patina, which is very soluble, which is insoluble. You know how it's a bluish turquoise color? That's copper rust. That's copper rust. They designed it that way. The designer chose copper because he knew that over time it would turn into that beautiful color. Unfortunately, the acid rain that was falling on New York City during this time was dissolving away the patina, and years of painting and tarring had hidden most of the problems from the park rangers. How would you solve the problem? Well, let me show you how they solved the problem. No talking, please. The noise, the sweat, the craftsmanship, all make a working poem that restoring the statue's clarity. She is affectionately called the Lady by all those who work on her, and when she emerges from that crisscross type Christmas, it will be the same liberty and light to the world that has stood in New York Harbor for the past 100 years. Hopefully now it will be strong and endure the ravages of storm and time. Piece by piece, there is a line of trial. Woodcutters and other iron workers in Local 580 are working out of a special workshop on Liberty Island. They're duplicating and replacing nearly every one of the 1,800 armature bars that support the copper sculpture from the inside of the statue. Each new stainless steel bar is unique. Many twist and bend in contorting shapes, duplicating the old original ones exactly. It's not exact, it won't fit. We don't have any tolerance at all. I don't give my fellow will bring a hot press. I put in a flat box here. For all the iron workers and sheet metal workers, this is a special job. Not because the work is intricate and unique, but because it is the Statue of Liberty. If pride had a sound, this would be it. It's like every woman now is a say, well, I took part in the Statue of Liberty. You know, I feel really good about it. It's proud to say. It's something inside, you know, you're proud. You know, it's a proud girl. You know, really do appreciate the skills that were and really put really first order the statue and the detail and the top of work. And what we're trying to do is just try to replicate that and do our job of making our statement and craftsmen 100 years later. The American Society of Civil Engineers is also contributing much expertise to the restoration project. They're reading and documenting the original impermeable structural work of the statue as designed by Justine Pipe Pretty easy.